We sometimes think of ourselves as living in the space age, but in reality, it's probably more accurate to say we live in an age of electricity. Our modern lives are driven by electrical devices, and the system that delivers electricity safely throughout the home is perhaps the most crucial of all home systems. Given the invisible and rather mysterious nature of electricity, wiring projects and repairs probably create more fear and nervousness among homeowners than any other home improvement project. There is some reason for this, because electricity can indeed be dangerous. The good news is that electricity behaves with a relentless, predictable logic, and simple wiring repairs are actually among the easiest of all household projects. They are also among the best projects for enjoying cost savings, since electricians charge a premium price for many repairs that you can do yourself in just a few minutes. To effectively perform all the electrical repairs in this book, as well as many more, here is the basic kit of tools and materials you'll need. 2 or 3 screwdrivers with insulated handles. These will be useful for making wire connections. A combination tool for cutting and stripping wires and cables. A utility knife, sometimes needed for cutting the insulating jackets on wires and cables. A needle nose pliers, which is useful for bending wires and making connections. Wire connectors of various sizes, which you'll use for making various connections. Spare plugs, lamp sockets, and lamp wire. Spare switches and outlet receptacles. These are so universal for wiring repairs that you're well advised to keep a selection of these on hand in your toolbox. A small selection of wiring boxes for switches, receptacles, and light fixtures are also a good addition to your basic kit. Not all of these materials are required for every project, of course. For each project on this DVD, we'll also show you exactly the tools and materials required. Okay, you're ready to begin your adventure as a DIY electrician. Electricity isn't a force to be taken lightly. Although basic wiring repairs aren't difficult, you should make sure you fully understand what you're doing. Many homeowners are reluctant to tackle wiring projects or repairs because home electrical systems can seem mysterious or even dangerous. However, it's possible to shut off power to a circuit, which makes working with the wires completely safe. Learning just a little bit about the electrical system will help you understand how power extends through your home and how you can shut it off. Home wiring systems are pretty straightforward. Power from the utility company's lines is delivered to a service mast on the house. That power flows through a meter, which measures the power consumed by the household. From the meter, the power travels to a service panel, which distributes power to individual circuits. The system is protected by bonding wires and a grounding rod driven into the soil outside the house. Circuits deliver power to receptacles, switches, and devices throughout the house. Nearly every electrical repair deals in one way or another with the wiring of these circuits. An electrical circuit is a continuous loop that carries power from the main service panel through the house and back to the service panel. Switches, receptacles, light fixtures, and appliances can be connected to the circuit along the way. Electricity flows from the service panel on hot wires and returns on neutral wires. These wires are color-coded to help you identify them. Most hot wires are black or red. Most neutral wires are white or light gray. If a circuit includes a grounding wire, it's usually green or bare copper. Each circuit is protected by a circuit breaker, a safety device designed to shut off electricity if an overload or short occurs in the circuit. These circuit breakers are one of the keys to working safely on wiring projects. Before touching any wires or devices in the system, you need to identify and shut off power to the circuit. Sounds simple enough, right? It is simple, but you cannot rely on the accuracy of a circuit map. Before working with the system, you must always test to confirm that the power is off. That's where circuit testers come in. A neon circuit tester was once a staple in nearly every homeowner's toolkit. These devices are inexpensive and reliable, but using one requires knowledge and understanding. Touchless testers are a fairly recent development. With this device, you simply hold the tester near the screw terminals of the receptacle, switch, or device. It lights to indicate power. Like the other types, plug-in testers confirm the presence of power. They also check for polarity, grounding, and circuit protection. A key printed on the device guides you through these tests. Let's start by testing a receptacle for power. First, go to the service panel and identify the circuit. Flip the breaker to the off position. Go to the receptacle. If you're using a plug-in tester, simply plug it in and check the indicator lights. To use a touchless tester, follow the manufacturer instructions of calibrating the device. Then, simply hold it close to the receptacle. Most neon testers can simply be plugged in to a receptacle by gently pushing the probes into the receptacle slots. If the tester lights, power is reaching the receptacle. Return to the service panel to identify and turn off the correct breaker. Continue until the tester confirms that no power is reaching the receptacle. For testing switches and other devices, use a touchless tester or a neon tester. To use a neon tester, remove the screws that attach the switch to the electrical box. Holding only the ears at the top and bottom, carefully pull the switch from the box. Place one probe on the bare copper grounding wire or the grounded metal box, and the other on each terminal screw, one at a time. You have to test each screw terminal to make sure no power is reaching the switch. The same principles apply to testing any fixture. Simply open the housing until you can see the connections between the circuit wires and the fixture. Aim the tester at the connections. To use a neon tester, carefully remove the wire nuts on the connections between the circuit wires and the fixture. Place one probe on the metal box or grounding wires and the other on each circuit wire, one at a time. If the tester does not light, no power is reaching the fixture. After you have confirmed that the power is off to the circuit, you can work on the system with confidence about your safety. Receptacles, or outlets as they're sometimes called, are incredibly reliable. The plain truth is, they hardly ever wear out. It's more likely that you'll decide to change the receptacle because you want to update its style than because it's not working properly. Occasionally, the metal contacts inside a receptacle wear out. When that happens, the receptacle no longer holds plugs firmly. Older receptacles made of hard plastic can sometimes crack and break. A cracked receptacle is a definite danger and should be replaced. Once in a while, a receptacle gets warm to the touch or buzzes or sparks when you insert or remove a plug. These are signs of a loose connection, which is a potential fire hazard. In any of these situations, the receptacle needs to be replaced as soon as possible. The only tools you need are a flathead screwdriver, a pair of needle nose pliers, and a circuit tester. You may need some wire connectors. You'll need some masking tape and a new receptacle. As with any electrical repair, the first and one of the most important steps is shutting off the electricity. Go to the service panel, consult the circuit map to find the circuit you'll be working on, flip the breaker to the off position. Return to the receptacle and use a plug-in circuit tester to confirm that the power is off. Receptacles are rated for amperage and voltage. Before you buy a new receptacle, check the ratings on the old one. Use a flathead screwdriver to loosen the screw and remove the cover. check the receptacle rating, and buy a new receptacle with the same ratings. Look for the screws that hold the receptacle in place. Loosen these screws. Holding the ears at the top and bottom, pull the receptacle out of the box. Depending on whether the receptacle is at the end or in the middle of the circuit, you will find either one or two cables inside the box. Using masking tape, label each wire and note where it is connected. The most important thing to note is which screw terminals each wire is attached to. Loosen the terminal screws and disconnect the wires. Look to see if the brass connecting strip on the receptacle is intact, or if it has been broken. Electricians separate this strip in the situations where the top half and bottom half of the receptacle are fed by different electrical circuits. It's a somewhat rare situation, but if you find this, you need to make sure that the new receptacle also has its connecting strip severed. To do this, simply use needle nose pliers to bend, then snap the raised tab on the connecting strip. Before connecting the new receptacle, check the ends of the wires. If they're nicked or scratched, cut the ends off and use a combination tool to strip the insulation off about 3/4 of an inch at the end. Use needle nose pliers to form a C-shaped loop at the end of the wire. Replace the wires as labeled. Basically, the black wires go to the brass screws, the white wires go to the silver screws, and the bare copper grounding wire goes to the green grounding screw. Your wiring might look a little different though, so the important thing is to attach the wires in the same way they were attached to the old receptacle. When all the wires are connected to the new receptacle, tuck everything back into the box, screw the receptacle's mounting strap screws to the electrical box, replace the cover, go back to the service panel and turn the circuit breaker to on. Plug in the tester. Follow the printed guide to test the receptacle for polarity and ground to make sure everything is connected properly. The receptacle should be powered up and ready to go. In older homes, you may find 2-slot receptacles. This is most common in homes built before 1950, where the wiring hasn't been upgraded. This can be inconvenient because so many modern devices have 3-prong plugs. Though these systems don't have a separate bare copper grounding wire, the system is usually still grounded through a system of metal conduit and metal electrical boxes. You can replace a 2-slot receptacle with a 3-slot by linking the grounding screw on the receptacle to the metal box with a short green grounding wire called a pigtail. Use a plug-in tester to verify that the receptacle is properly grounded and ready for use. Some receptacles may be connected to wires with push-in fittings rather than with screw terminals. In this case, you can detach the wires by inserting a small nail or the tip of a small screwdriver into the release opening on the back of the receptacle. When installing the replacement, though, it's a good idea to use the screw terminal connections rather than the push-in connections. Screw terminals are more secure than the push fittings, and nearly all professional electricians use the screw terminals rather than the push-in connections. Most people rarely think about light switches. We turn them on when we come into a dark room. We turn them off when we leave. We try to teach our children to do the same. Even beneath the surface, most switches are simple devices. We've cut away a simple switch to show you how it operates. The most common switch is known as a single-pole switch. Electricity arrives at the switch through a hot wire connected to the lower screw terminal. When you flip the switch on, the metal arm makes contact with the upper screw terminal. This completes the circuit and lets power flow between the screw terminals and through the hot wire connected between the upper screw terminal and the fixture controlled by the switch. Switches are very dependable, but they do wear out. The average light switch is turned on and off over 1,000 times a year. If a light switch feels warm to the touch, buzzes, or makes sparks, it needs to be replaced. The tools you need are pretty basic. Just a flathead screwdriver, a pair of needle nose pliers, and a combination tool. You'll also need a circuit tester. One type is a simple neon circuit tester. To test a switch for power, you place one probe on the bare copper grounding wire or the grounded metal box, and the other on a terminal screw. If the tester lights, power is reaching the switch. Touchless circuit testers make testing for power even simpler. You simply move the device around the area of the switch. The materials you need include masking tape and a new switch. You may also need a green or bare copper jumper wire for grounding and some wire connectors. The most common type of switch is the single-pole switch. A single-pole switch controls a set of lights, a device, or a receptacle from a single location. This type of switch has 2 screw terminals and a grounding screw. The switch lever is marked on and off. The amperage and voltage ratings are also marked. Another type of switch, called a 3-way switch, controls a set of lights or device from 2 locations. These switches are always installed in pairs. 3-way switches have 3 screw terminals. One of these has a dark finish. This is called the common screw terminal. The other 2 screw terminals have bright or light-colored finishes. They are known as traveler screw terminals. The 4th screw terminal is a grounding screw, and it is attached to the metal strap of the switch rather than to the switch body. In large rooms, 4-way switches are installed between 3-way switches to control a set of lights from 3 or more locations. 4-way switches have 4 screw terminals. All switches are rated for amperage and voltage. The ratings are usually engraved in small numbers on the metal strap. On the back, you'll find a rating that indicates the recommended wire gauges. The switches you'll see here are common ones, but the placement of screw terminals and recommended wiring configurations can vary. All manufacturers provide wiring diagrams, and it's important to study those diagrams and to follow manufacturers' recommendations. Your switch replacement project will start with you shutting off the power to the circuit controlling the switch you want to work on. Return to the switch and use a circuit tester to confirm that the power is off. Loosen the screws and remove the switch cover. Look for the screws that hold the switch in place. Remove those screws. Holding the ears at the top and bottom, pull the switch out of the box. Ignore the green copper grounding screw for the moment and focus on the screw terminals attached to the body of the switch itself. 2 screws on the switch body indicate a single-pole switch. 3 screws means you have a 3-way switch, and 4 screws tells you that the switch is a 4-way. By the way, if the switch has a white wire attached to it, you may notice that it has been tagged with black tape or paint. This is a technique used by electricians to indicate when a white wire, normally a neutral wire, is being used instead as a hot wire. Use a flathead screwdriver to loosen the screw terminals and then remove the wires from the switch. Look carefully at the markings on the old switch and buy a new one with the same voltage, amp, and wire gauge ratings. Inspect the ends of each circuit wire. If the wires are damaged, cut the ends off and use a combination tool to strip the insulation from about 3/4 of an inch at the end. Clamp the wire in the opening that matches its gauge. Pull firmly to remove the insulation. Use needle nose pliers to form a C-shaped loop at the end of each wire. Connect the bare copper grounding wire to the grounding screw on the switch. If for some reason your old switch did not have a grounding wire attached to a grounding screw, just keep watching for now. Near the end of this project, we'll show you how to deal with that variation. Reattach the other wires to the main screw terminals, just as they were with the old switch. Tug on the wires gently to make sure they're all firmly attached. Carefully tuck the wires into the box. Make sure you install the switch right side up, so that up is on and down is off. And replace the switch plate. Now, let's look at a three-way switch, which is identified by the three wires attached to the body of the switch. One of the three screw terminals will have a different color than the other two screws. This is called the common terminal. And it's important that you label the wire attached to this screw before you remove the old switch. Use masking tape to tag the common wire. Then, disconnect the three wires attached to the body of the switch, as well as the ground wire attached to the strap of the switch. Inspect the ends of the wires for damage and cut and strip fresh ends if needed. Attach each wire to the new switch just as they were attached to the old switch, ensuring that the common wire is attached to the common screw terminal. Attach the grounding wire to the grounding screw and you're done. Now let's look at a four-way switch, which you'll identify by the presence of 4 screws on the body of the switch. It's a somewhat rare kind of switch, but if you're replacing one, here's how to do it. With the switch pulled slightly away from the wall, pay attention to the 2 cables entering the back of the electrical box. Each cable will have a red and a black wire, plus a white wire and a bare copper grounding wire. Label the red and black wires from one of the cables using masking tape. Disconnect all wires on the old switch. Connect one pair of red and black wires which you tagged with tape to one set of screws on the new switch. 4-way switches have screws that are color-coded, with 2 lighter screws and 2 darker screws. Attach the tagged pair of wires to one of these pairs of screws, either the lighter or the darker pair. Now, attach the remaining red and black wire to the other pair of screw terminals. If you're replacing an older switch, you may have recognized that it did not have a grounding screw or grounding wire attached to it. At one time, this was common practice, but it is no longer allowed by code. When you replace such a switch, you do need to make a grounding connection. One very easy way to do this is to use a green grounding jumper wire available from your home center. Simply attach one end of the jumper to the grounding wires in the box using the wire connector provided. The other end of the jumper goes on the green grounding screw on the switch. If no grounding wires are present, make the connection to ground by attaching one end of the jumper to the metal box. With standard switches, lights are either on or off, but there are many other times when you need something in between. A dimmer switch can be useful anytime you need to moderate the lighting conditions in a room. From a candlelight dinner for 2 to movie night with the family. Dimmer switches reduce light levels by cycling the power to the light fixture on and off very rapidly. The result is less light, as well as less energy consumed. Dimmer switches work best with incandescent lights. Most won't work at all with compact fluorescent bulbs. To replace a standard switch with a dimmer switch, you need only a few tools: a screwdriver, a combination tool, and a neon or touchless circuit tester. You will need wire connectors, masking tape, and a dimmer switch. Dimmer switches are available in several types and styles. For years, the most common type of dimmer switch has been a dial-type dimmer switch. You simply rotate the dial to increase or decrease the intensity of the light. A slide-action dimmer typically has an illuminated face, which makes it easy to find the switch in the dark. Many have an on-off switch plus a lever to slide up or down for more or less light. A digital fade dimmer has a rocker to adjust the level of light and a delayed off feature that provides light as you leave the room. For a fixture or set of lights controlled from one location, you need a single pole dimmer. For a fixture or set of lights controlled from two locations, you need a three-way dimmer. Most styles are available in both types. Most dimmers have wire leads that are connected to circuit wires using wire connectors. Although many dimmers have two leads, some also have a neutral lead. Other dimmers have screw terminals. On these dimmers, you simply transfer the wires from the screw terminals of the old switch to the screw terminals on the dimmer. We're going to show you how to install dimmer switches in several situations, but remember, wiring configurations vary depending on the manufacturer. Also refer to the wiring diagram that comes with the dimmer and follow manufacturer's instructions. Let's start with a switch that controls one set of lights from one location. To make sure you buy a compatible dimmer, look carefully at the old switch first. Go to the service panel and flip the circuit breaker to the off position. Remove the screws and take off the switch plate. Remove the screws holding the switch to the electrical box. Holding only the ears at the top and bottom, carefully pull the switch out of the box. Be careful not to touch the wires or screw terminals on the switch because you've not yet checked for power. This switch has two screw terminals plus a grounding screw. It is a single pole switch. A single pole switch can only be replaced with a single pole dimmer. Before you go shopping, add the wattage of all the bulbs in the fixture controlled by the switch. Dimmers are rated for the load that they can carry. Select a dimmer rated above or equal to that total wattage. Read and follow manufacturer's guidelines regarding this and all other wiring matters. Use a circuit tester to confirm that the power is off. If you're using a neon circuit tester, place one probe on the bare copper grounding wire or on the grounded metal box, and the other on each of the screw terminals. If the tester lights at any time, power is still reaching the switch. Return to the service panel and turn off the correct breaker. Test the switch again. If the tester does not light, no power is reaching the switch and it is safe to handle the wires. Testing for power is even easier using a touchless circuit tester. This switch has been installed using the push-in connectors. Removing wires from a push-in terminal can be frustrating and can damage the wire. Since we will not be reusing the switch, we'll save some time and aggravation by simply cutting the wires off near the switch. This gives us nice clean ends to work with. Remove about a ½ inch of insulation from each wire using a wire stripper. Use wire nuts to connect the ground wire of the switch to the bare copper grounding wire in the box. Connect the two remaining switch wires to the wires remaining in the box. They are interchangeable. Tuck all the wires and the dimmer body into the box and install the screws that attach the dimmer to the box. Installing a dimmer is slightly more complicated if you're replacing a three-way switch, but not much more. A three-way switch has 3 screw terminals, or 3 wire leads, plus a grounding screw. This three-way switch also uses push-in connectors. Before cutting the wires, locate the common terminal on the back of the switch. This wire will need to be connected to the common wire in the new dimmer switch. Mark this wire using a piece of masking tape. Most three-way dimmers will have their common wire marked. With our switch, we consult the installation instructions and find that the black wire is the common wire. The remaining red wires are interchangeable, and the green wire is for ground. We're in the home stretch now. All you have to do is tuck all the wires in the dimmer body into the box and install the screws that attach the dimmer to the box. Install the switch plate, restore power to the circuit, and test the dimmer. Replacing a lamp socket and switch is one of the most common of all household wiring repairs, and it's one of the easiest. It's also one of the safest, since you'll be working on the lamp while it's unplugged from the electrical system. Lamp sockets and switches get a lot of heavy use. What with turning lights on and off and replacing bulbs regularly, when a light socket and switch go bad, the signals are pretty clear. A lamp that flickers, even though the bulb is fully screwed in, is beginning to fail. Another sign is a switch that loses its snap when the knob is turned or the chain is pulled. First, let's look at some of the various types of sockets and switches available. You'll probably want to replace the socket with another one that looks more or less identical to the bad one, but you can also make upgrades. For example, you could replace a simple on-off lamp switch that operates by a knob with a pull-chain three-way switch that will accept three-way light bulbs. In addition to the light socket itself, here are the tools you'll need. A screwdriver. Yes, this project is that simple. Just a screwdriver is all you'll need. Let's get started. First, unplug the lamp, of course. Set the lamp on a well-lit work surface. Then, remove the shade and light bulb so you can examine the socket. If your lamp has a metal bracket that holds the shade, remove this piece, which is called the harp. One easy solution you should consider is to check the flat tab on the bottom of the light socket. If the socket is a very old one, sometimes the metal tab will be pressed flat on the bottom of the socket. If you're feeling lucky, you might try bending the tab upward a little and see if the lamp works. More likely, though, the socket has seen the end of its useful life and will need to be replaced. To remove the socket, look for an engraved marking with the words "press" or "press here." You may have to press rather hard, but pressing on the socket at this point will loosen it from the base, so it can be removed. Pull upward gently on the metal socket, which will pull it free from the base. There may also be a cardboard insulating sleeve that will also need to be removed. Check the wire connections on the screw terminals. If either of them are loose, simply reconnecting them, then reassembling the socket may solve your problem. If there are no obvious loose wires, unscrew the lamp wires from the socket and remove it. If necessary, remove the old socket base and install the new one by simply screwing it onto the lamp. Tighten the set screw. Attach the lamp cord wires to the screw terminals. This is just a little trickier than you might think. The neutral wire, which on most lamp cords is marked by faint ridges on the cord, should be connected to the silver-colored neutral lamp wire. The smooth half of the lamp cord should be attached to the brass-colored screw terminal. Loop the wire around the screw terminal in a clockwise direction. Then tighten the screw down firmly on the wire. Slide the socket shell and insulating sleeve over the socket, making sure the switch and switch slot line up. Then push the socket into the base until it clicks firmly in place. Reattach the metal harp for the lamp shade, then insert a light bulb and test your work. There you have it. For $5 in parts, you've salvaged a lamp that was perhaps worth many times that amount. Most lamp cords last as long as the lamps themselves. But like anything else around the house, they sometimes meet bad ends, especially in homes with kids and pets. Damaged cords are fire hazards and can cause injuries. Even if the lamp still works, a damaged cord should be replaced as soon as possible. There is no reason to put off this project. The parts you need cost less than $10, and the repair should take less than half an hour. The only tools you'll need are a flathead or Phillips screwdriver, a wire stripper, and a utility knife. You will also need lamp cord and a plug end. Be sure to buy enough cord to reach from the lamp's usual spot to a convenient outlet, plus a foot or two. The first step in any electrical repair is to make sure no electricity is reaching the fixture. In this case, that's simple. Unplug the lamp. Now, remove the shade and the harp. Push up the guards, squeeze in the sides, and lift. Take a look at the outer shell of the socket. You should see a place marked Press. Press that spot and lift off the shell. Under the shell, you may find an insulating sleeve that protects the wire connections. Pull off this sleeve. The lamp cord will be connected to the socket at the terminal screws. Use a screwdriver to loosen these screws and then unhook the wires. Set the socket aside. Grasp the cord near the base and pull it out of the lamp. Thread the new lamp cord into the lamp and out the socket end. Use a utility knife to separate the wires, then a wire stripper to remove the insulation. Feel each wire. One should be smooth and one ribbed. Hook the ribbed wire around the silver screw terminal so it forms a clockwise loop. Tighten the screw firmly. The insulation on the wire should just touch the head of the screw. Now connect the smooth wire to the brass screw in the same way. You're in the home stretch now. Slide the insulating sleeve and then the outer shell over the socket. Make sure the screw terminals are fully covered and the switch from the socket fits into the sleeve slot on the shell. Press the socket assembly back into the socket cap until you hear it snap into place. Install the new plug onto the end of the cord. There are countless plug styles to choose from. Many require no tools and very little time to install. Reattach the metal harp for the lamp shade, then insert a light bulb and test your work.